Hello, good morning, good afternoon, good evening. Well, on the behalf of our shareholders, Abrilia, we warmly welcome you to our new Geodiversity and Geoconservation talk. That is the second session of our new webinar series, hosted by the UNESCO Chair in Geodiversity and Geoconservation. Our UNESCO chair is based in the University of Minho in Portugal, and this UNESCO chair is supported by a network of 10 universities from different countries, as well as 2 international organizations. We kindly ask you to keep your micros muted the whole time, and this presentation will be recorded and later uploaded in our YouTube channel. However, we will stop recording once the discussion begins. If you have a question or a comment during our session, please type it in the chat or use the raise hand feature. And today we have the pleasure to introduce Dr. Christopher Cleal. He is the Honorary Research Associate at University of Bristol and is an expert in late Carboniferous paleobotanic. He recently published, together with Sarah King of the York Museums Trust, a very interesting paper on the journal Geoheritage, entitled Museum Collection as Geoheritage, which is exactly the title of our talk today. Exito, geoheritage is centrally very important component of our natural heritage, yet it is unfortunately still overlooked by society. So thank you very much, Chris. We are very happy to have you here today with us, and the floor is yours.
Thank you very much. As it was implied, the presentation I'm about to give is partly based on the paper that I published last year with Sarah. It's part of a series of papers that we were hoping to put together, reflecting different aspects of geoheritage and geoconservation by members of the British Institute of Geological Conservation. As Sarah and I have both spent most of our careers working in the museum sector, it seemed sensible that we took over this side of the problem of geoheritage and its representation in the museum world. I will first apologise that most of the examples I will be giving will be based on British museums and institutes, simply because that is what we know best. But I would also maintain that most of what we want to say has a global relevance. Many years ago, 10, 12 years ago, a very interesting paper by Maria Hendricks et al. Looked at the way that geoconservation has evolved as a professional discipline. And one of the important points she made out is that often when a subject develops in this way, it tends to develop its own jargon, its own language. This can be seen in many different fields as well as geoconservation. The idea is that this helps improve accuracy and clarity in what we're talking about. Frankly, I think that's a nonsense. It doesn't. It rarely does. It, in fact, often tends to obscure communication. But we are where we are, and geoconservation has indeed developed its own set of terms to describe what we try and do. And I think I just need to clarify for that reason this confusion which can occur with some of these terms, what exactly we mean by this. Now, I know that ProGeo are currently organising a working group to try and explain what some of these terms mean. We're still working on it, but at the moment I'm going to use one of the 3 key terms, which I'm showing on the screen now, geoheritage, in a particular way. And in effect, it's to explain what are the key sources of the evidence on which the geosciences are based. Where do we get our information from to interpret and understand our science? And this can, in effect, be fall into 2 subsets, what is sometimes referred to as in situ geoheritage, which are basically field sites, geosites, and ex situ geoheritage, which are collections. And that brings us on to museums, which is the main theme of this talk. Now, when the history of museums, and particularly natural history museums, is discussed, their foundations are normally put into the cabinets of curiosity, the Wunderkammer, as our German colleagues like to call them. These are particular types of collections which developed mainly in the 17th and 16th centuries. They were based on personal ownership. They were collections developed by individuals, usually men, wealthy men. They reflected their interests. They were very eclectic collections. They didn't really have a particular focus. Their intention, in fact, wasn't really to explain what the collections were about. They were there to reflect the collector. They were a social demonstration of the educational, cultural status of the person involved. So in some ways, I think it's possibly misleading to say these are the origins of museums in the way we think of them today. Things started to change more in the 17th century with the birth of the Age of Enlightenment. Now, the early proponents of this, particularly René Descartes, really regarded the idea that science must become empirical based on measured data. He regarded that data which wasn't based on measurements was less reliable. And so the early work of the Enlightenment scientists, if we can call them that, were by people like Robert Hooke and Newton, were based on physics, astronomy, and using data which could be measured. This meant that the natural sciences tended to be less involved in this because it becomes much more difficult to measure the data based on animals, plants, fossils. But things did change in the 18th century, partly because of the development of colonialization, and people were going out into much wider parts of the world, bringing back specimens which didn't relate to what we see in Europe. And so we have people starting to look more carefully at how do you make the natural sciences a more robust way. Natural sciences became empirical, but not by measuring things, but by comparing things. This is where the ideas behind taxonomy and comparative taxonomy started to develop. Key to this was, of course, Carl Linnaeus, but there were a whole range of different people involved in the botanical, zoological, and paleontological sciences who were trying to take these ideas on board. The result was that collections started to be accumulated. You needed the collections to be able to compare between what became known as species. And this led to the development of the basics, the basis of natural science museums. In Britain, one of the key proponents of these ideas was Sir Hans Sloane. He was a wealthy aristocrat. But when he was younger, he traveled quite extensively, particularly in the Americas, in the Caribbean, and he accumulated a large number of specimens, which he brought back to this country. He also became a physician, a doctor, which meant that he was particularly interested in items which had a medicinal relevance for producing medicines. He produced a massive collection of specimens at his home in London. This is one of his publications where he illustrated specimens which he had found in the Caribbean, but the specimens themselves were often placed in his home. The top image there, I'm not sure actually if that is purported to be his collection. I'm not sure whether that is actually true. The way they're dressed looks a bit earlier, but I show this as it reflects the sort of massive collection of material that he started to establish and build up. They had a distinct theme, or some of them had a distinct theme. They had medical relevances, but he tended to collect anything which was reflecting the biodiversity and life of the areas that he was interested in. On his death in 1753, there was a bit of a problem because his house needed to be sold and the collections needed to be disposed of. And it became widely recognized that they were important scientifically. And he knew the royal family, the British royal family at the time, and so they persuaded them to, after his death, to acquire the collection, effectively to buy them. And these, together with some of the other collections, made the basis of the British Museum. At the time, probably one of the largest national museums in the world. These attracted large audiences to come and see the marvelous specimens he had accumulated. And this continued into the 19th century, in the middle 1800s, until it became evident that the collections had just got too large for even the buildings which they were housed in. And so the natural history material was transferred to another building in South Kensington, what is now the Natural History Museum in London, one of the largest natural history museums in the world. It's also one of the most popular. It was announced this morning. Apparently, this is now the largest, the greatest public venue for visitors in Britain. It had over 7 million visitors. Not the only museum, however, that developed at this time. Another one in Paris, partly through the work of Georges Cuvier, the great zoological anatomist. This collection originated from the collections of the royal family of France, their cabinet of curiosity, as it was called. But obviously, after the revolution, something needed to be done, and it was made the foundations of the major natural history museum in Paris, which exists today. And also, like the Natural History Museum in London, is one of the great resources of paleontological data in the world. About this time also, university museums started to appear. With the Age of Enlightenment, there was an increase in the idea that you should be teaching the natural sciences to students, and to teach, obviously, subjects like this, you needed specimens. It was not enough just to stand up in front of people and talk to them and say, this is what is his. You need to be able to show them the specimens on which the ideas were based. One of the great university museums is in Cambridge. It was established in the late 1600s by John Woodward, a major proponent of paleontology in the United Kingdom. It seems rather a shame that it is now called the Sedgwick Museum, after Adam Sedgwick, the rather cantankerous Victorian paleontologist. I don't know why they used his name, not John Woodward's, but there you are. The museum still exists. It was initially as a teaching museum, specimens to show to the students, but it is now open to the public also. But it is not like places like the Natural History Museum, which depends largely on visitors for display, but also, like you can see in the bottom right-hand corner, it is there to show specimens in a more educational sense. They don't have the expansive interpretive displays that the places like the Musée in Paris and the Natural History Museum in London have. There are a number of these university museums still in existence, and they're all major repositories of significant geoheritage collections. Another one which I have worked in Birmingham, the Lapworth Museum, has a wonderful collection of material of Silurian and Carboniferous age, reflecting the geology in that part of the world in central England. There's John Clatsworthy, the director, who's responsible for looking after this marvelous collection. During the 19th century, another major change was occurring with the development of the Industrial Revolution. This had obviously major sociological impact, with the growth of new towns and cities away from the older metropolitan areas. And this caused the growth of a new class of people, middle classes, or the expansion of the middle classes and the more educated working classes, and resulted in the growth of societies, local scientific societies, usually called philosophical and literary societies. The term scientific hadn't really developed its modern day sense at that time, but they encouraged activities amongst a wider group of people, not just the wealthier aristocratic members of society, but also, as I say, working class and middle classes. They would encourage lectures, they would encourage projects and collecting activities by those people. There are numerous ones of these in Britain, and I know also in Germany and in France and elsewhere. One of the ones I'm just going to show here is the Yorkshire Museum, or York Museum, which was established in the 1830s by John Phillips. John Phillips was the nephew of William Smith, the famous English stratigrapher. But he promoted the museum particularly as a place for discussing geological evidence, and it still is now active, and it's in fact where my co-author Sarah, she's here on the bottom left-hand corner, is working. And it's a wonderful museum, both in terms of what can be seen in the displays, but also the collections. It has major collections from the Yorkshire Jurassic coast and also from the coalfields in Yorkshire. Even some of the smaller towns have their museums. This is currently my hometown where I live in Newbury. It has a small, very nice museum there. On display, it has some geodiversity materials, although when you look at this, you think you'd question whether it has a significant geoheritage result, would be a significant geoheritage resource. But in fact, I found later that in fact they do have quite an important, if small, collection of specimens of Paleocene flora from a site which is just outside of the town in Newbury. Never been properly worked on. I talked to Sir Peter Crane, who did his PhD on the floras of this age, and he didn't know of this. I suppose this just reflects how important it is that we all know about what local museums have, because there may be secrets in there which could potentially be very important, because the curators aren't specialists in these fields, are maybe not aware of the importance. Another aspect of museum development, which is less relevant to Europe, more to North America, is the role of philanthropy in museums. I suspect largely because of the feeling of many Americans, they don't like the idea of governments organizing things. They rely more on philanthropy. And in fact, many of the major museums in the USA in particular came about through the gifts of wealthy people. One of them, for instance, Andrew Carnegie, the wealthy industrialist who became also a philanthropist. He was a social reformer, but he also paid or helped develop what's become known as the Carnegie Museum in Pittsburgh, which is a major collection, largely with displays on things like dinosaurs. I suppose all American museums have to have dinosaurs because they have so many of them in their country. But it also has major collections of other aspects. So it's clear that over the years, museums with geoheritage resources have evolved in different ways through different, following different routes and different pressures. And largely, up until relatively recently, they've been regarded as good things to have. They reflect well on the city, the country, the community in which they are based, and probably relatively little questioned as to why they should be there. But nowadays, things are changing. The world is changing financially, and we're now having to answer the questions: what are these collections for? Why are we asking the taxpayer to pay for large buildings to keep them in? Curators' salaries. I know curators aren't paid a vast amount, but they still have to be paid. And the other curatorial materials, which are needed to support the such institutions. Now, if you ask most members of the public what are geoheritage collections for, what are these museums for, they'll say, well, it's for exhibitions. It's to show these fossils and minerals in a way which will appeal to the general public. And of course, this is very important. This is one of the best ways we have of demonstrating features of the earth sciences to the wider public. I know there are increasingly many books and television programs which are allowing us to demonstrate this. But the great thing with specimens and museum collections is that they're actual objects. And it becomes much easier to attract, particularly the younger audiences, when you've got a reality there, rather than just something that's seen on a screen. This, of course, can lead to its own problems, though, because particularly the more popular institutions, especially when they're in tourist locations, like in the Natural History Museum in London, you can get enormous crowds milling into the exhibition halls, which introduces major problems in terms of crowd control and protecting the specimens. But I would suggest maybe this is a problem we should welcome and try and solve rather than try and counter it, because it means that we are actually getting the message through to a wider audience, and which is surely one of the major functions of the museums. But there are also other ways other than exhibitions. This is National Museum Wales, where I used to work in Cardiff in South Wales, and we would several times a year hold outreach events where we would take it over, and this is the main hall, entrance hall to the museum, and we would put out tables and the curators would sit there with the specimens, and we would bring in large numbers, we would get large numbers of visitors coming in to talk to the curators about the specimens, to have the stories told about the specimens, what do they show, what do they mean. And this is a much more direct way of explaining the relevance of the collections than just the label on a specimen. We also had many events outside. This was one that outside of the actual building of the museum. Our most popular events were at the Royal Horticultural Society show, which is a national show held in a park just outside of just a few minutes walk from the museum, where we would have a marquee and we would bring specimens, and the curators would be there to talk to people about what the specimens were and what they meant. The great benefit of this sort of event was the fact that you would be talking to people who would probably not or may not go to the museum. The number of times when I would be there talking to people about my fossil plants, and they would say, well, that's interesting, that's fascinating. Where can we see more of these? And I would say, well, there's a museum just over there. And they say, where? And I say, that big building over there. Oh, they would say, we thought they just had pictures in there. And it allowed us to get to an audience which we would otherwise find difficult to access, to interact with. The didactic role of a museum also has a long history, of course, initially with the university museums, where they were used for undergraduate teaching. But in the 20th century, it has become increasingly evident that schools and the younger children have an interest, and their education can be facilitated through visits to the museum. Many of the larger museums now have a school service, and they will organize visits. They will either be facilitated by members of the school service, who would often be trained teachers who have moved into the into the museum sector, or would be facilitated by teachers who have been trained by the museum service. This is often a very popular way of getting messages over to the children, because you're not teaching, well, partly because it's a day out for them, but also we're not teaching them by just talking to them, not showing them pictures. We're showing them real object, and this often will engage with the children to a much greater extent than just purely talking about them with images. This we found particularly relevant to teenage children, who can often be put off by old-fashioned teaching methods. But if you talk to them with specimens, with reality, this can make a much more engaging way of teaching. This, of course, is great if you live near to the museum or the school is near to the museum. And for city museums, this is usually fine. But the National Museum of Wales, where I worked on, was intended to cover the entire country. It's not a large country, but even so, if you were in North Wales and you wanted to come to the museum in South Wales, it was perhaps a 6-hour round trip, and which was all sorts of practical problems in terms of financing and time. So we developed a schools loans boxes, which were basically boxes with specimens in with some interpretation, which could be loaned by the schools, and they would have them for a few weeks, maybe a month, and they would allow the children to be able to access these specimens. There can also be a link with traditional geoheritage, geotourism. Often this is in terms of interpretation centers. This is one I visited just before the pandemic, in fact, in central China, at the Huanggang Diabishan Geopark, where they had a marvelous interpretation center. This was not intended to be a collection as such, but they did have specimens, and so it did fall into the general remit of collections as geoheritage, and provides another link between the general world of extrinsic and intrinsic geoheritage. So the collections are important for all of these things. Obviously, they underpin the exhibition work. But what about the collections in terms of other wider significance? Now, of course, collections are used for exhibitions. If you've got wonderful specimens like these, fish of treated sperm frond and crystal, you have no problems using these for exhibition work. There's no question as to their relevance for display and outreach work. These sort of exhibitions, we can see, use specimens, but they are normally the really spectacular ones, the ones which are rare. And as we know, anybody who works in the museum sector will know that the vast majority of specimens aren't like this. They're small hand specimens, scientifically very important, but it's very difficult to make these into a stunning display like as you normally have in the display halls of most museums. So why are we keeping these? Why do we need to keep these small specimens which most people rarely see? What is their relevance? One of the types of specimens we often talk about when we're discussing this are the taxonomic type specimens. These are the specimens which are often said to define the species on which we work. And undoubtedly these are important, but this is partly a misunderstanding. These do not define the species on which we work. A taxonomic type specimen defines the name, not the species. That is important when you're looking at the collections as a whole. To reflect this, I'm just showing here an image from the work of Mike Eager, an English paleontologist who worked on the non-marine bivalves from Europe. And he was interested in the variation in morphology that describe a species. This is from one particular species, Carbonicola protea, and he demonstrated quite a range of variations. He would select one specimen as the holotype of the name. So this is the holotype of Carbonicola protea, but it does not define the species. The species is defined by all of them. And we need all of those specimens, to understand the species as a whole. We need the museum collections to include all of these specimens if we're going to understand the species. Another aspect of geology which depends on specimens is biostratigraphy, the distribution of fossil species through the stratigraphical column. The sort of range charts we see on the right, this is from one of my papers from a few years ago, demonstrate the ranges of the different species. But this is not the data. This is a demonstration of the ranges. The ranges are based on specimens. We use matrices, such as on the left, which show the occurrences of the species in each of the localities. But without the actual specimens, these are just ideas. These are not really these are not really scientific documentations. We need the specimens on which each of the dots or the little crosses on the matrix are based for it to be a really scientific model. Similarly to plant biogeography or formal biogeography, we can look at the distributions of the species, and we can try and establish how those species vary across a large area. And this particular one was based on some numerical analysis I did again a few years ago, where we can see clear patterns in the different coal fields across Europe and Eastern North America. But this isn't on its own enough. This is based on data. This is the matrix of data on which those analyses were based. But each of those crosses are based on specimens in museums. And if the robustness of the model, which I proposed, is to be tested and verified, we need to be able to refer back to the specimens on which the model was based, on which those X's are based. And of course, new techniques are evolving. We have, on the left, we have the great British paleobotanist Mary Stopes from the early part years of the 20th century, who used, for the time, high technological techniques, microscopes lit by great bulbs of water to focus the light. This was probably as good a technique as you could use at the time. And she was able to demonstrate evidence of seed attachment to tree sperms and evidence of the structure of peat in the coals. But today, of course, we have new techniques, we have new methods, new equipment. On the right, we have an image of an ironstone nodule, which we discovered in the collections of the Natural History Museum, which, when you look at it, shows very little evidence of structure. But under the SEM, the scanning electron microscope, we were suddenly able to show detailed structure of the cells, of the stomata, and of the hydrothodes, which was just unseeable in using the techniques which Mary would have used back in the 1900s and 1910s. So we need the specimens so we can return to them using the new techniques which we have now available. For this reason, our argument has been that geosites and geoheritage in many ways represent a continuum from the where we find the specimens through to where the specimens ultimately end up. They inform on each other. The specimens help inform on the geosite. It helps tell us why those geosites are important, what's the scientific basis of its importance, which you cannot actually see directly at the site itself. But similarly, the geosite informs on the specimen in the museum, because it helps us tell us how old the specimen is in field context. So they are part of a continuum, all parts of the same concept of geoheritage. But then it equally becomes important when the geosite disappears. Many of the geosites which have been investigated in the past have been lost, either because they were artificial workings, or the site has simply been lost through erosion. And so all we have of the evidence on which, the geoheritage evidence on which our scientific understanding and models are based, are in museums. An example of this is that the Stonesfield slate, so-called slate, it's not a slate, it's a limestone, but it was worked underground in Stonesfield near Oxfordshire. And this yielded some of the most important fossils in Britain, including the earliest dinosaur remains, which William Buckland worked on in the 1820s. This was obtained from underground workings. I have actually been underground there at Stonesfield. We actually opened it up briefly back in the early 1980s. I wouldn't don't think you can get down there anymore. And this is the only photograph I could obtain, but it is impossible to collect any fresh material from there. So our only understanding of the important dinosaurs, dinosaur faunas, but also there's an important Jurassic flora there, which I published on some years ago. The only way we can investigate these biotas any further is by looking at the museum collections, in particular, in this case, at the Oxford University Museum and the Natural History Museum in London. So our case is that geoheritage generally underpins the geosciences. Whether it's in situ geoheritage or ex situ geoheritage, it is vital for strategies of education, exhibition, outreach, and geotourism, for explaining to the world what we can see, what we understand, how the world has evolved and how it will continue to evolve. Things like climate change, evolution, biogeographical change, mineral resources. But more importantly, it is important for research. Without these collections and without these sites, we will be unable to continue to research on these subjects, which are increasingly seen as vital to the prosperity and healthy development of a modern day society. This is sometimes not put forward enough, I think, to the general public, and particularly to our paymasters, the politicians. I think we need to be able to explain this more clearly to a wider audience. And this, if we were going to allow these resources to be available for our future development of the subject. Thank you.